Your child has an acute leukemia. Each year, parents of about 100 Czech children hear this horrible sentence. Let me refrain from the personal seriousness of this disease, and let's look at it as a scientific challenge. Acute leukemia is caused by a proliferation of immature cells that would otherwise become blood cells. In case of acute lymphoblastic leukemia, these would be lymphocytes, and for acute myeloid leukemias, these would be all other blood cells. This is the classical way how we look at the treatment efficacy in life-threatening disorders. We are seeing proportion of patients who are alive at certain times after diagnosis. Here we see pretty much a natural curve which shows the course of the disease when insufficiently treated, because this was late 60s. So this was really a grim prognosis of the patients with acute lymphoblastic leukemia. And fortunately enough, soon afterwards, with the introduction of classical chemotherapy, the outcome started to look much better. And and even more so, it is becoming better and better when we look at figures from later time period. So you may ask, why is that? The first thing that you would imagine is that perhaps more and more drugs are becoming part of the anti-leukemic treatment, right? And this would sound logical, except this is not true. The vast majority of today's success in treatment of acute leukemia in childhood is achieved by more and more efficient combination of the drugs that have been around since 1970s. Acute myeloid leukemia is treated with quite a different type of chemotherapy. It's in general more aggressive, yet the prognosis is somewhat worse than for acute lymphoblastic leukemia. But it is also improving. And one particular subset, which is unfortunately very rare, of acute myeloid leukemia is worth mentioning here, as it is quite nicely treatable with recent and elegant approaches. This rare subtype is characterized by malfunctioning retinoic acid receptor. So let's look at the function of this receptor in normal cell and in leukemia. In normal cell, this normal retinoic acid receptor sits on the DNA and allows transcription of the target genes. The malfunctioning retinoic acid receptor, which is fused with a protein called PML, is doing quite the opposite. It turns off the target genes, and the target genes they would normally enable the differentiation of the cells into healthy white blood cells. So these cells in leukemic conditions, they are stopped from differentiation, and they behave like leukemic cell. So what we can do now with them, we can treat these leukemias with two different substances. One of them is all-trans retinoic acid, which acts on the retinoic portion of the fused protein. And this turns the target genes on and allows the differentiation of leukemic cells into harmless white blood cells. Unfortunately, though, this effect is not achieved in all children, and also it is not durable enough. However, if you combine it with arsenic trioxide, it is durable and it is efficient in almost all cases, children or adults. You may wonder when these two substances were started to be used. Altered retinoic acid is around since about 1960s for various other medical indications, and arsenic trioxide has been first used more than 2,000 years ago in anti-leukemic treatment by Hippocrates, and it was actually used even in the medieval times and in traditional Chinese medicine, and this was reinvented in the beginning of this century. So, unfortunately though, we have what we are left with for majority of the children is the classical chemotherapy. So the way how classical chemotherapy is given is not left at the discretion of the physicians who happen to be on duty that day, but they are meticulously described in the so-called treatment protocols, which describe the doses, timing, as well as diagnostic procedures that need to be taken. And physicians, because of the standardized administration of the drugs, they have become masters of clinical management of the patients, including management of the adverse effects, which are unfortunately quite frequent. We do diagnostics, and our main task is obviously to confirm whether the child we are investigating has or doesn't have leukemia, which type of leukemia, then all other features that are important for treatment categorization. This is an on-stage picture of one busy Thursday afternoon in our laboratory, and you can see people who, if you ask them if they do just research or just diagnostics, they would most likely they wouldn't be able to tell, because they do usually both. And important part of our research, obviously, is to improve diagnostics. Among other techniques, we use a powerful technique which is called cytometry, which has the advantage of looking at cells one by one. Therefore, we immediately see whether we are looking at normal specimen of a bone marrow, which is manifold like here, or whether we see an expansion of one subtype of cells. In that case, we can analyze them separately, and we can look whether they are. We can look whether they are uniform like here, or whether they are more diverse. And diversity is important because it gives strength to the cells. It allows them, for instance, to move to distant sites, to hide from where they can hide from chemotherapy, or they can evade the chemotherapy effects just simply by being more resistant. So in science, it is sometimes quite important to ask, am I looking at the complete picture? So to the point here, are there any other leukemias besides lymphoblastic and myeloid leukemias? Yes, they are. Somewhere between lymphoblastic and myeloid leukemias there is a small subset of leukemias which are called leukemias of ambiguous lineage. There are 4 categories, and you see them on this picture. The biphenotypic leukemias, they are characterized by one population which shares features of at least 2 lineages. In bilineal, we can see 2 different or even more different populations, each belonging to a different lineage. In undifferentiated, just 2 few features, and switching leukemias, they switch from one type to another. So remember, I was talking about the treatment protocols, right? How important they are. So how is it with these ambiguous lineage leukemias? Whereas lymphoblastic and myeloid leukemias have their respective protocols, the recommendation for ambiguous lineage leukemias has been lacking. And moreover, from the scientific point of view, this is a very tricky subset of patients because, as I said, this is very rare. So it is very difficult to gather enough data for statistical analysis. So we decided to get high with a little help from our friends, which we did, and this is the main result of our study, which we started in 2012. Every scientist is very pleased when their work is published in a nice journal. So we were very pleased to have a top-ranking hematology journal, but perhaps even more than that, we learned a lot. We learned what was the approach to these patients, which was ranging from let's give them acute myeloid leukemia type of treatment just to kill the worst of the cells, or jumping back and forth between 2 different types of treatment, etc. And we collected much more students from around the world. Much more patients from around the world, and than had been collected before, and therefore it led to a possibility to analyze them statistically. So here you see that if the patients started on lymphoblastic type of treatment, they were much better off than those children who started in the other types of treatment. In addition, we could look at subsets of these patients. So in one subset, which is quite frequent, and you could see that virtually all patients who started on myeloid leukemia type of treatment either died or their disease returned in the form of relapse. So definitely we should not give this type of treatment to these children. You could also ask scientific questions like, I was mentioning diversity a while ago. Is it then important to whether we see a uniform population or several populations? We were kind of skeptical that there would be some difference, because when we looked at selected patients, we actually found evidence that both of the subsets were genetically the same. So it's one leukemia developing to 2 different conditions rather than two concomitant leukemias. However, our data convinced us that really diversity is important So both for the children who started on lymphoblastic type of treatment and for the other children, it was the prognosis was better when they had just one subset of leukemia cells. So during that time we became experts on ambiguous lineage leukemia, and when you are an expert on something, you usually try to cherish the object of your interest. And personally speaking, I would much rather, while we will keep looking at the ambiguous lineage leukemias, I would much rather them to disappear as a therapeutic subset, because we want to have we want to give the best possible guide to the physicians and let each child with ambiguous lineage leukemia to be treated according to the existing experience. So diagnostics helps children today. Research helps those children who come in the future, and there is sometimes a thin line between these two. We are, despite all the progress in acute leukemias, we are not done yet, and we will continue to work on both diagnostics and research until each child gets their best possible and yet bearable treatment, or even better, until the leukemia can be prevented. Thank you.